Okay, this video is Algebra 2, section 4.4c, and it's all about graphing parabolas from the factored form of the equation. Okay, so far we've talked about graphing parabolas when they're in vertex form, and we talk about taking the basic shape of the parabola, right, which is right there at the origin, and then we talk about moving it to the left or the right or up or down and making it more narrow or wider or whatever. And that's great if the equation is in vertex form. We talked about how to change it from and put it in vertex form. But there's another way that you can graph the parabola, and that's by putting it in factored form. So let's take a step back. Remember earlier in this section when we talked about solving an equation by factoring. So if I take this equation and I want to solve by factoring, first I make sure it's equal to 0, and it is. And then I try and factor it. So let's see. If I do my two parentheses, I know the signs are different. So plus and minus. I'm going to have x times x. And then in order to multiply and get 12, I'll start with 4 and 3. And I think if I put the 4 over with the minus and the 3 with the plus, and so now if I check it, the outer is -4, the inner is +3. That's going to work. That's going to give me the negative x in the middle. So this works. So now it's factored. And then to go on and solve, I would say x equals, remember you said each parenthesis equal to 0. So either x equals -3 or x equals 4. Okay, so that's what we did earlier in Unit 4. We can solve by factoring. Well, how do I use that when it talks to when it comes to graphing? Well, number 2 says use your calculator to graph the function above and find all zeros. So what I'm going to do is I'm going to put in just this part, the x squared minus x minus 12. And if I were to put that in my calculator and graph it, there's my equation, x squared minus x minus 12. If I graph this, okay, there's my parabola. And the question was find all zeros. Well, I could go in and do that, second trace and, choose number 2 for zeros, but I don't really need to do that because remember, aren't the zeros where it crosses the x-axis? And you can tell this parabola is going to cross the x-axis. It looks like right here at -3 and then over here at +4, right? So the zeros are x equals -3 and +4. So back to the question, number 2, use your calculator to graph the function, find all zeros. Well, the zeros, remember we said were at -3 and also at 4. Number 3, how do the zeros of the parabola compare to the solutions from number 1? So how do these answers compare to what we got for the solutions up here? Well, obviously they are the same. Okay, so what does that tell me? Well, what that says is when you solve an equation, right, in this case the quadratic, right, so it's a parabola, when you solve an equation, what you're actually doing is you're finding the zeros. And remember, another name for zeros is the x-intercepts. Another name, which I'm not sure we talked about that much, is the roots. All 3 of those words mean the same thing. So really, when you solve an equation, that's telling you something about the graph. Okay, so look at the next part. It says, without using a calculator, find the x-intercepts of the following parabolas. In other words, find the zeros. Well, if the zeros are the solutions, then imagine this equals 0. We could factor it. Let's see, if I factor this, I know I need a plus and a minus. In order to get that +2, I think I'll go with a +4 and a -2. Check it, outer and inner, that's going to give me +2 in the middle. And if I finish solving, x equals -4 and x equals 2. Since those are the solutions, that means those are the x-intercepts of the parabola. That's where the parabola crosses the x-axis. Okay, same thing here. If I'm finding the x-intercepts, that means I'm setting it equal to 0. I'm finding the zeros. And then if I factor it, I'm going to have, let's see, can this be factored? I need both minus. I'll start with a 2x and a 2x to get the 4x squared. And for 15, let's see, if I try 5 and 3, 5 and 3. Will that give me negative 16 in the middle, outer and inner? Yep, that works. And so my solutions are x equals positive 5/2 and x equals positive 3/2. So those are my x-intercepts. Those are also the solutions. Okay, so how am I going to use this to actually graph a parabola? Well, so now I know where it crosses the x-axis, but how do I know, where that vertex of the parabola is? Well, let's go back and look at the one that we had on the calculator. I know it touches the x-axis at -3 and 4. I can't quite see the bottom of the parabola here, so I'm going to adjust the window. I'm going to have the y min, I'll say, go down to -15. See if I can see the bottom of that parabola. There it is. It looks like the vertex almost looks like it's at -1. How can I find that vertex? Well, isn't that the minimum of this parabola? So if I go to second trace, and instead of finding the zeros, I could find the minimum. See, number 3 says minimum. So I'm going to choose number 3, left bound. So if I put the cursor just to the left of the vertex and I press enter, I'm going to move the cursor just to the right of the vertex and press enter. Remember, on guess, we don't care about that. In this case, notice it says the minimum happens at x equals 0.5. X equals 0.5. So think about this parabola up here. I'm going to go up here and kind of draw a graph, a little bit about the graph. So on the, here we go. On the x-axis, we knew that it crossed over here at -3 and over here at 4. And then remember, the vertex was way down here at 0.5. Well, just eyeing it up, doesn't that vertex look like it's halfway between the two zeros? In other words, is 1/2, that ordered pair, remember, was 0.5 comma something, is 1/2 exactly halfway between -3 and +4? It is. 1/2 would be right in here. That's exactly halfway between those two x-intercepts. So in this box, if I have a factored form, how can I find the vertex? Well, the x is always going to be halfway between the zeros. Okay, the x is always going to be halfway between the zeros. And then how would I find the y-coordinate? Well, if I know the x-coordinate of the vertex, anytime I know x, in order to find the y, you can just plug that back into equation. So I'm going to say substitute x into equation. Okay, so let's put it all together. Here's what I'm saying. Remember on letter A above. Okay, here's the equation that we are looking at. Let me kind of highlight it here. Here's the equation that we are looking at. Y equals x squared plus 2x minus 8. We already said the zeros are at -4 and 2. The zeros are at -4, and then 2. Okay, well, what would halfway be between -4 and 2? Well, the way I think about it, aren't those 6 units apart? From -4 to 2, that's 6 units. So halfway would be 3 units from one side. So if I go 3 units from either side, right in the middle, wouldn't that be -1? That's 3 units from -4. It's also 3 units from 2. So that means that the vertex has an x-coordinate of -1. How did I know that? Because it was halfway between the zeros. And so how do I find the y-coordinate so that I know the actual ordered pair? Well, what we said right here for number 2 is substitute that x into the equation. If I put -1 into the original equation in place of x, if I put in a -1, then I'm going to have y equals Well, negative 1 squared is positive 1, plus 2 times negative 1 would be minus 2, and then minus 8. So I just plugged negative 1 up into the original equation everywhere I saw an x, and that's going to come out to be negative 9. So that means the vertex is at negative 1, negative 9. So the vertex is way down here at negative 9. And if I were to, since I know it crosses here and here, that way I know how to graph the parabola because I know the zeros and I also know the vertex. Okay, let's go to this second example. So on this one, here's the equation we're looking at, right? So we know that the zeros were at 5/2 and 3/2. So 3/2 is here, and 5/2 is here. Okay, so what would halfway between those two be? Well, wouldn't halfway be right here at 4/2? Oh, well, wait a minute. 4/2 is just 2. So that means the vertex has an x-coordinate of 2. And if I want to find the y, I'm going to substitute that back into the original equation everywhere I see an x. So I'm going to have y equals 4 times, well, 2 squared is 4, minus 16 times 2, and then plus 15. Well, that's going to come out to be, let's see, 16 minus 32 plus 15. 16 minus 32 is negative 16. And if I add 15, that's going to be negative 1. So my vertex is at 2, negative 1. So if I were to put on here, remember this was 2. If I come down to negative 1 right here, and I know it crosses at these zeros, so there's, whoops, didn't quite cross it. There's the parabola. Okay, so look at the next part. It says sketch the graph of each parabola using factored form. Okay, so let's practice. First thing we do is we put it in factored form. So if I put this in factored form, I'm going to have x and x. I know they both have to be minus. In order to get 15, I know I need 5 and 3. Okay, so that means the zeros are at 5 and 3. Okay, so I'm going to come down here. Imagine my x-axis. Here's 3. Here's 5. That means the vertex happens halfway between 3 and 5. So the vertex happens at 4. Okay, so if I plug in 4, and you know what I'm going to do? I think what would be smarter than plugging it into the original, I'm going to plug that 4 into the factored form. If I put a 4 in place of that first x, I'm going to have 4 minus 5 is negative 1. And if I put a 4 in place of that second x, 4 minus 3 is positive 1. And in factored form, doesn't that mean we're multiplying these two things? So the y value is negative 1 times 1, which is negative 1. So if my vertex is at 4, negative 1, and I know it crosses at 3 and 5, then I know what my parabola looks like, right? Okay, let's go to the last example. First thing I need to do is put it in factored form. So how about we do 3x and 3x. And then I need to multiply, let's see, I'm going to have one of each, right? A positive and a negative. In order to get 7, I'm going to use 7 and 1. So check that. Does that give me negative 18? Yep. Outer is negative 21. Inner is positive 3. That's going to work. So that means my zeros are at negative 1/3 and positive 7/3. Okay. So my vertex is halfway between there. I got to figure out halfway between negative 1/3 and 7/3. Well, let's see here. Here's negative 1/3. Here's 7/3. So how much distance is there between there? Well, in order to get to 0, here's my, sorry about that, here's my y-axis. In order to get to 0, I would be coming over 1/3, and then I have another 7/3. Isn't that a total distance of 8/3? So if the total distance is 8/3, then halfway would be 4/3. Well, if I come 4/3 this direction, 4/3 before I get to 7/3, wouldn't that be 3/3? Right? Or I could say 4/3 away from this negative 1/3. Wouldn't that land me at 3/3? But hey, isn't that just x equals 1? So that means the x-coordinate of my vertex is 1. And remember, I think the easy way to come up with the y value is to plug that 1 into your factored form. If I plug 1 into the factored form, 1 in place of x, that's going to be 3 plus 1 is 4. If I plug in a 1 here, it's going to be 3 minus 7 is negative 4. That means my y-coordinate is 4 times negative 4 is negative 16. So if I'm going to graph it, here's x equals 1. We'll say negative 16. Whoops. I need to scooch that over. We'll say, how can I move that? Okay. We'll say is way down here, negative 16. I know it crosses at negative 1/3 and 7/3. So if I were to draw that parabola, it's going to be, all right, try and at least hit the point, something like that. Okay, so this is how we can graph using factored form. First we find the zeros, and then we go halfway to find the vertex. That should help you get started on your homework.